Hi, I'm Jim Baccarosa, and welcome to Aviation Tech Talks. In this podcast series, we'll be speaking with industry experts and pioneers, delving deep into the latest developments and advancements in aviation tech. From futuristic aircraft designs to cutting-edge digital solutions, we'll be exploring how technology is shaping the future of the industry. So buckle up and join us for an exciting ride as we take off into the fascinating world of aviation tech. Welcome, everybody, to our latest episode of Aviation Tech Talks, where innovation takes flight. In this week's episode, we have our first guest from across the pond, so we're going international, and that guest today is Dr. Ip-Shing Fan. Dr. Fan, thank you so much for joining us.
Well, you're most welcome. Thank you for having me.
Yeah, we're very excited to talk about some of the things you're doing at Cranfield. But for our listeners today, I'd love to just give a quick background here and read some of your bio. So here, Dr. Fan is a senior lecturer in enterprise systems at Cranfield University, leading the digital MRO and DART EC, supporting aviation transformation and operations and maintenance. He is leading the digital MRO and Hangar laboratories in Cranfield DART EC initiative. The complex is a realistic representation of airport ramp and hangar environment to study the interactions between aircraft, engineers, airport and hangar facilities, ground vehicles, and drones. The digital infrastructure support aircraft digital twins work to maintain the accurate configuration in the information world of airworthiness as the engineering health status of the aircraft structure and systems to predict and prevent failures. Fan has a bachelor's degree in industrial engineering from the University of Hong Kong. He completed his engineer training in one of the largest toys and plastic manufacturers in Hong Kong. He finished his PhD in the use of AI to optimize manufacturing scheduling in the early days of AI. One of the major projects he led was a consortium across 10 European countries to investigate the reasons why enterprise systems projects fail. He looks at the world with a socio-technical lens to explore the complex interactions between people systems and technology systems. Recently, he started a new master's program in aviation digital technology management at Cranfield University. So what an impressive bio. Thank you, Dr. Fan, for joining us. Did I miss something?
Oh, no. You're perfect in the introduction.
Well, we're really excited to talk about innovation today. And I'd love to just maybe see if we could start out with, we just read your bio for our listeners today, but maybe give a little more of your background and kind of your role at Cranfield and kind of what you're doing there at the university.
My background have, in a sense, a similar path to you, that I do not start off with aviation. I was trained as an industrial engineer, manufacturing engineer. In the earlier days when we start to work with industry, it was in those exciting times that we introduced lean manufacturing, business process reengineering, enterprise resource systems to see how we can transform manufacturing and make it work better. So we've been working in those areas for many, many years. Cranfield, the place that I work, is a rather unique place. We are developed on a site that was created for the Royal Air Force to participate in the Second World War. So some of us will remember earlier this month we commemorate D-Day, and there were reports that I read that somebody was flying over Cranfield, and there were over 1,000 aircraft in the airfield getting ready for the D-Day invasion. So this is all part of the very rich aeronautical heritage in Cranfield. And after the war, we were decommissioned from a military base to a specialist experimental and research facility for the creation of jet aircraft. So we still have our operational runway, We can take a 737 or 320 into the airfield. We own our airspace. We also own the airport management as well. And we are the first UK airport that have virtual control tower, so that our air transport controllers no longer sit in the glass box. They sit in a room with panoramic screen with the technology that enable them to see much better than if they are in the glass box. And through the history, we have the whole range of design, manufacture, wind tunnel capability. In fact, the first hydrogen-fueled electric-powered aircraft that Civil Avia made was converted and test-flown from Cranfield. So while I do not start with an aviation background, I begin to get involved with many of the aviation characteristics and things that we do. I think it's similar to the story that we interviewed you some time ago, that having the manufacturing background, we realized that aviation is actually not very slick, although it is very safe. So using some of those concepts get me to start to work in the whole area of aftermarket support, airline operation, MRO operation, and that's where we are.
Yeah, I think that's great for our listeners. Dr. Fan and I collaborated on some papers, and I think we had a joint kind of appreciation for our backgrounds, where my degree was in industrial and systems design engineering, and my very first project in the consulting world was at a huge printing company. So on the shop floor building, how do we get data off print, giant gravure and offset printers, and getting that data was really a great eye-opening project for me. And what a great place to work that you have, and the history behind that airfield, and really part of just changing the world, right? I mean, just the history there has got to be great. I had an opportunity, if anyone ever gets the chance, to head to Tucson to the Pima Air and Space Museum there. I was lucky enough to catch a pilot who flew missions from there over Germany in World War II. He signed up for the Air Force when he was 17. And just the stories alone of landing there. I'll have to share this because I thought it was an incredible story, where he was flying back, sustained damage to his bomber, and the hydraulics weren't working. So he had no brakes, was landing the plane on the runway, and couldn't stop. And remember, it's a 4-propeller plane, and there were other aircraft parked at the end of the runway. And so he had to make a choice, and he veered it off the runway, got stuck in the mud, got the plane stopped. But the crew chief came running out and said, "What did you do to my plane?" He says, "I got it back in one piece." So it was just the stories that come out of there are just amazing. So I think the history is great that you get. So, but today's topic's really about the future and what we're seeing in innovation. So I'd love to start out with what sparked your interest to move from industrial engineering into more aviation related. What was the key interest for you that made that switch for you?
Well, aviation is always of interest, but particularly when I do the switch, it's actually, in a sense, reorient my industrial interest from manufacturing, where in the main, we design everything. We have the suppliers to provide us with the components new. We put it in the assembly line. We know the process, and we can actually create a system of working. And when I begin to work with some of the MRO colleagues, looking after the maintenance of aircraft, then I enter into a slightly different role, where quite often there's a lot of plan, but until you open up the aircraft, you may not really know what you're going to find out. And that brings in a level of excitement, the complexity, the uncertainty, the having to do quick thinking on the spot, still keeping everything safe, collating information, getting teams of people to work together. Perhaps we constitute a supply chain for the particular problem right away. And of course, by now I learned the lingo. I know we call that AOG. And that is a very interesting thing. So from something that we can do a lot of pre-planning to something that we need to do things on the fly, that is exciting. And I find that really interesting.
Right. And it's an incredible challenge for engineering as well, because as engineers, we love to plan, design, test, retest, right? But you don't always have that luxury with aircraft. And so, what do you see, as some kind of exciting trends in the aviation world around innovation that's happening today? What sort of trends are you seeing?
I think that the trend have a high level aspect. The very high level, I would say, we are actually in the very exciting time, because if you look back, the aircraft that we fly, the metal tube with two wings stuck on two sides, those concepts exist for the last 40 to 50 years, and we haven't fundamentally get a lot of changes. But now, when we start to think about electric, hydrogen, UAV, eVTOL, urban air taxi, and elements of space commercialization, space tourism, that's actually bringing us to the point that many new vehicle concepts, new propulsion concept is coming into thinking and reality. Not necessarily immediately, but they're all on the horizon. So all the work that make them work and work economically and safely, and all the support infrastructure, open up the space that we need to totally redesign our airspace and air operation. That is tremendously exciting. People in the last 50, 60 years do not have that opportunity to do the big revolution. Now we are on the cusp that we can actually make those design and move.
Yeah, no, it's very exciting. We're on a step change in the world of aviation, really. So, there's a lot of topics there, but could you highlight for our listeners what you think are one or two of the most groundbreaking technologies, and how you anticipate those technologies to impact the aviation world in the next 5 or 10 years?
Well, if I'm greedy, I'll touch on three.
Okay.
So I think number one is everybody talk about AI now. So we begin to see different elements of AI. Some of them are the customer facing, the chatbot, large language model to help people to deliver the interaction and information services. The other side is probably a lot of the digitalization, where if we understand the industry as you do very well, our industry was designed and built around paper. So now the opportunity to perhaps not use so much of the paper, but get into devices that can capture the information so that we have them as a way to use it and exploit them in the future. That is now beginning to happen, which is great. But the third angle is this big realm of robotics and drones. So we talked a little bit earlier about the hydrogen and the electric air vehicles. I don't foresee that when they fully go into operation, we're going to use human in hazard suit to refuel hydrogen aircraft. The whole use of robotics, the development of it, will today have an impact of reducing the human workload and take away some of the dangerous tasks, but more importantly, prepare for us to be able to work on those future hydrogen or space vehicle that we are beginning to bring into being. Again, not immediately, 10, 20 years time, they're not so far away.
Yeah, and that's actually an interesting point you bring up. I have a lot of debates with folks in the industry about electric versus hydrogen, future of aviation. And one of the components there is, how do you refuel those hydrogen aircraft? It's very hazardous. It's very dangerous. And you bring up a point there about we need robots instead of humans in hazmat suits to do that. Could you touch on any of the technologies you've seen of robotic development for that specific purpose?
they are in the book, but rather than kind of look at them specifically, I think one of our advantage is that we have our eyes also on non-aviation and begin to see things come into it. I don't know the US in detail in the restaurant trade that well, but if you go to Hong Kong, China, Japan, Korea, a lot of the restaurants have robots that will deliver your meal to your desk. You use a mobile phone, use an app, order the thing, pay for it, and a robot will come next to your table with the things that you need. So if you talk about the robotic technology, a lot of the fundamentals are not that hard. Of course, we need to ruggedize them so that they can work for aviation. There are more subtlety that we need to ensure that the safety is ensured. But if we look across the board, where we see robots in the retail trade, we also see a lot of robotic innovation in construction, where some of the diggers, the yellow machines, no longer need a human inside, that they are carrying hard and heavy tasks. There are those pick and mix components that I would say with the right environment and the right situation, bringing them together is much more a system integration challenge than a component innovation challenge.
Well, here in Chicago, there is a sushi restaurant that does have the robot. And let me tell you, I'm the father of 3 little boys who think that's amazing. So I can't wait to when they're older and robots are refueling the plane that they're getting on. They'll think that's pretty amazing as well. What do you think that you talked about integrating systems? Where do you see, we always talk about kind of where we see technology advancing and some of the innovations. Can you point out, or do you see any challenges? And maybe talk, to our listeners about those challenges and what we should be looking for to overcome them.
I suppose part of our conversation, and as we plan, we think about startup, funding is always an immediate challenge that every startup have to address. But beyond the finance, I think one of my observation is that new ideas, entrepreneurs tend to start from people with great vision. But we need an environment so that they can marry up to reality. I'm in a fortunate situation in Cranfield, where we have the airfield, we have our own fleet of aircraft, and for research and teaching purposes, I have a retired 737 aircraft with the full history of maintenance in records and in paper form and all the relevant information that I can begin to use it to ask those questions. What does it really mean? Take, for example, if you put robotics, I can have a robot that can run around the aircraft, but not unless it is carrying out one of those regulated tasks for maintenance or inspection that I can take away the human effort. Then I'm just adding a cost rather than actually achieving benefits. So an environment that can allow ideas to be tested in reality, in the full, to me, is a very important aspect to avoid those mistakes. And if the new start innovation idea is grounded in the right reality, then this path is going to be safer, more efficient, and work. Another example I have is about drones. Everybody loves drones, but actually there are a lot of work that maybe fixed infrastructure cameras can do the job, because for those who are not necessarily a drone flyer, even the best stabilization system will kind of come into difficulty if the wind gust is more than, say, 14, 15 knots. By 20 knots, no drones are really capable of flying around in a maintenance and operation situation. So to get the robustness in the way that it can fully operate in the real environment is important. AI, we talk about image detection, but most of the images that we use today are created in a controlled environment. Whereas during the day, the sun moves along, and so the shadow change shape. Temperature, dew points, all those reality of the environment are not fully incorporated or maybe not available for the innovators to ground their development into reality. So the path between having an idea and MVP to the point that it is deployable, that industrialization too often takes more time and kill more startups than it need to be. So if we have the right environments to help people grow, I think everybody benefits.
Yeah, I 100% agree. I have a saying that it always takes twice as long, costs twice as much, and it only works half as what you expected it to at the end, no matter what. So I think you make a great point of we've got a lot of innovation. We've got a lot of folks talking about drones, AI, some of these additional technologies, but we've got to marry that with reality and get some actual functionality out of these. So I think that's a great point to look for. And, given where I think Cranfield and some of the projects you're working on, you mentioned cameras, heat, so you mentioned temperatures. One of the things I was really fascinated about is your Hangar of the Future. I think that's an amazing project that you're working on. I'd love for you to share some of that with our listeners today and maybe incorporate, highlight some of those technologies that you're developing, testing, implementing in reality, in a real hangar there, because you have that facility. We'd love to hear about that.
Okay. Well, let me see if my screen sharing technology work.
Sure. Yeah, if we can even see some pictures of this. But for our listeners, one of the things that Dr. Fan is working on at Cranfield is what we call the Hangar of the Future, where they're incorporating a number of the different technologies that we just touched on in a real life airport hangar with aircraft, integrating drones, different camera technologies. I think you have some robots also, right? I believe.
We do. This is a screen of the Cranfield Global Research Airport that I mentioned, that we have the runway, and then as the old airport layout for the Royal Air Force Station, we have the old hangars that we've converted. That's where I'm sitting in the Digital Aviation Research Center. So it is all the great stuff that we can do. But in terms of the hangar, it's part of the Digital Aviation Research Center facilities. I'm going to jump a couple of slides. So this hangar space, a few sorts of it, we have our retired aircraft under the canopy. The canopy itself is cabled up, so I can put different sensors up the roof line that look down. I have camera systems that look down that can do surveillance. I can use PTZ camera in terms of looking at specific spots, magnify them, and look for inspection, representative damages, dents, bird strike, lightning strikes, etc. I can fly drones around the facilities, but more importantly is that as an airfield active, we shouldn't be flying drones without kind of interfering, shutting down the airport. But I can put nettings around the hangar so that within the 30 meter by 30 meter space, I can let drones operate in a near real atmospheric environment. So they can test out wind gusts, temperature, other effects that may affect the operation. That can all be working within. We have some of the robotics. The orange one is a new one that we acquired that have 80 kilogram payload that my colleague Angelos is now building up the payload for carrying out inspection, doing maintenance tasks. The little baby by its side is actually a lab robot that we use to experiment our path navigation, improve out the algorithm that we can do indoors before we put on the big robot. So it reduce the debugging time for traveling around and so on. So yeah, these are all part of the facilities that we have. There's something in my slide deck that I haven't had a chance to mention as innovation, is that 3D printing is getting to be more and more mature. On the screen on the left-hand side is actually a 1 meter long plastic 3D printing, composite type thing that we can do. But on the bigger picture with the two robots is actually metal 3D printing. So one of the demonstration piece was commissioned by Airbus, which is a 5 meter long aluminum wing spar. And beyond that, we have a 1.5 meter long titanium piece as a rear bulkhead of a fighter aircraft. So demonstrating that we may be able to mature the technology sufficiently that we can make the part in situ. Right now, when something goes wrong and we want to find a part, we hear about all the supply chain problem. But even in the good days, if you need a critical part, depending on where you are, it may have to ship out from 2 days, 3 days, 7 days away. Rather than if you have the capability to make it somewhere nearby, you can actually get it done in a day. So many of the AOG, disruption to operation, they become much less of an issue if we begin to be able to make parts in situ. And that will totally transform the way that we need to manage our supply chain and get things going. So these are some of the technology that we have in place that we are working on and maturing with different partners, but integrating them so that it actually can be delivered as reducing turnaround time, reducing maintenance efforts, all those practicality of integration that I mentioned.
Wow, that's really impressive with all the different use cases, on-field inspections. You can look for all kinds of damage. You mentioned bird strikes, repairing material, delivering the material. I think it's great, and testing it in real life. Right, that's a real plane in a real hangar with a real environment. So I'd ask then, a couple of pieces of my question here is, then how does, Cranfield, you talked about partners, how do they kind of help support innovation, and maybe then talk about one or two kind of success stories that have come from something that Cranfield worked with a company that have come out of the university. I'd love to hear those as well.
Okay, so because of our history, Cranfield is unique in the sense that we are postgraduate only. So we don't have any undergraduate. So the number of students on campus is not that great compared with a more normal university. But out of that is the support for industry development. So we have an innovation office that supports maybe ideas from staff or industrial collaborators who come, that they can start small with a couple of desks in an office. We partner with the Barclays Bank. I don't know how big Barclays is in the US, but it's quite a significant bank in the UK. And we have this place called the Eagle Lab, that the entrepreneur will be able to receive financial advice and support from the bank side, the technology support from our side. And as they begin to develop, they can move into a place that we have workshop facilities that they can use. And according to the kind of project that they do, they can then lean together with some of the academics and facilities. So there's a company that started, and then they're creating effectively a ground-based docking station. So a quadcopter drone, after its operation, can fly, drop into the place, get its battery recharged, replaced, download the data, etc. So it is a unit that they can roll out and then support drone operation. And because with our airfield, so they can do their work, do their development, and then arrange with the airport so that they can actually test all of these in real operating environments and build the confidence with the investors and customers. So it's been growing and developing. We have other things that we do on 3D printing. It is not a well-known thing, but you know that the James Webb Telescope, the space telescope, go up, of course, from the US. But there's a very critical piece inside, which is the splitter to split the light into the different spectrum. That was actually manufactured in the precision engineering lab in Cranfield. And that's gone up to space with you.
Well, that's great. That's an exact application of some of the things that we're learning that came directly out of Cranfield. So that's great. So, before we wrap up here, anything that you would want to give a piece of advice for aspiring entrepreneurs out there who bring an innovation to the market? Anything you'd want to share with them?
I think the talent and the skill is the most important thing. So we can have an idea. Then I think is finding the right partner that can ground things in reality, and then cultivate people so that the organization can grow. There's a cusp point that when an organization grows beyond 10 people, there's a kind of a cliff edge that many startup or growing company fail because the people do not necessarily work together well enough and then sustain that new idea and maturity and growth. So partner with the right people, rooted in reality, continue to attract the good talent and build that capital resources will be the foundation of any practical innovation that can deliver impact to the business.
Great. Well, that's perfect advice. Dr. Fan, how can our listeners get a hold of you, or if they want to learn more, where can they go? Where should they go?
Let me share one slide. I have my contacts up here. So if people
wonderful.
want to find me, then there's a QR code of our course as well as my email address. So we are very happy to talk to people and share about what we do.
Great. That's perfect. So for those just listening to the audio, you can reach Dr. Fan. His email is i.s.fan@cranfield.ac.uk. Excuse me. It's our first international guest today. So, Dr. Fan, really appreciate you spending some time today chatting about innovations. A lot of exciting stuff over there, especially in the Hangar of the Future, and look forward to staying in touch and watching some of the things come out of there. So thank you very much.
Thank you for having me.
Great. Thanks, everybody. Stay tuned for our next one. We'll see you soon.